we've got a job today. We need to disconnect this motor from the supply. No problems. This is actually a pretty easy job because it's supplied from this GPO right here, this socket outlet. So, what do we need to do? We need a couple of tools. Well, first of all, what's actually wrong with the motor? Let's turn it on and try it out. Should we turn it on?
By all means, let's give it a shot.
So here we go. Doesn't sound good. Doesn't sound good at all. Probably what's happened with this motor, sounds like there might be a bearing gone in the motor. So we need to disconnect the motor from the supply and send it off to a repair shop. So we need some tools, don't we?
We do. So we're going to go and get some tools and we'll be back and we'll go through the process. Okay, so before we do the job, obviously we need to make sure we've got the correct tools. So in front of me, I have lines and pliers, fully insulated, 1000 volts. Some electrical tape, so we can tape up any bearing cabling, of which we will use BP connectors or single screw connector and double screw connectors. We'll put those on the end of the cable if we need to, tape them up so that they're nice and safe. We have our fully insulated screwdrivers, and most importantly, we have our multimeter, which is one of the most important tools we can have as electricians, because this will keep us safe and keep us alive, and that's pretty important for us. So we'll be using that. And Mr. Pope, if you'd like to explain the difference between the danger tag and the out of service tag.
Now, talking about safety, really important. You've got two different types of tags. Out of service tag and the danger tag. So, which one is used for which application? The danger tag keeps you safe from getting electrocuted. When you isolate the circuit, you put this danger tag on the isolator, a circuit breaker or an RCD or whatever, so that no one else can come along and operate that isolator so it energizes the circuit. You want to work on a de-energized circuit or an isolated circuit. The out of service tag, that goes on the machine that's now out of service because you've isolated it or because it's getting repaired. So, both keep you safe. As an electrician, this one keeps you alive. This one puts the actual machinery out of service so no one uses it. Both keeping you safe, two different jobs. As an electrician, this is the one that is going to be most important for you. Now, we need to talk about the steps of isolation. So, let's go through the steps of isolation as we do the job.
Let's go for it.
You might have seen this poster around the place. You need to memorise the steps on this poster. Vitally important to keep you safe, keep you secure, make sure you get home at the end of the day. So the first step is to identify the circuit. So I can see that this machine is fed from this GPO here, okay? And on the GPO, we have written DB1A CB25. So you can see on this GPO, DB1A, distribution board 1A. So what I need to do here, this one's relatively easy because all I need to do is turn off the switch, pull out the plug. But we're going to show you the full process so that you know exactly what you need to do. So we have gone through step one, isolate the circuit. And it's DB1A CB25. Now I have a look around here and I can see just over here, just there beside us, is distribution board 1. That's what DB1 stands for, distribution board 1. Beside it, I can see distribution board 1A. On the GPO, it's got written DB1A. So that's where I'm going to go. And I need to look for CB25. That means circuit breaker 25. So I'm going to go over there now and isolate the circuit, which is step 2. Okay, so we're at distribution board 1A. I've already unlocked the board and I'm going to have a look because I need to find CB25, circuit breaker 25. So open it up. Now normally you've got a distribution board schedule on here. It tells you what feeds what. So I'm going to have a look down here. 25 power bench sander. That looks pretty good. I think that's where we need to be. That's the bench sander. So I look over here. I look for circuit breaker 25. Well, that's interesting. There is no circuit breaker 25. I wonder how they do that. Ah, have a look up here. We've got an RCD 25 bench sander. So don't just go down here and go, oh, I don't know where to look. Look over the whole board. Okay, really important. If it wasn't on the schedule, it wouldn't be on the board. Usually. Sometimes some people are a little less than efficient or effective when they fill out these schedules. Use your brain as an electrician. Use your brain. So let's isolate the breaker. Now, next thing I have to do, according to the 7 steps of isolation, so this is step 3, tag lockout circuit. I have my tag here. Now it says here, this equipment switch valve, I've got to fill in all the details on here. You've got your name, your inspector position, what does that say? Sorry, department position, branch, date, time, details and so on. Just fill it out. For the ease of this video, I'm not going to fill it out. I think you can follow the instructions on filling out a danger tag. Then I'll take the danger tag and I should be able to feed it through there. Can I do it on this one? Possibly not. Okay, but what I can do, I can see here, there is a little hole in the side of the breaker. This won't fit through. So I've got to get a bit creative. How am I going to get creative? That hole there is roughly the size of a paper clip or a piece of wire. If I get a piece of wire or a paper clip, put it through there, tie it off, then tie the danger tag on, I've made safe. Alrighty, so next step on the isolation procedure is testing equipment on a known source. Why do we do that? Well, we want to make sure that our test equipment is operating correctly. If our test equipment isn't operating correctly and we test on the thing we've isolated, we might get a false sense of security that it's isolated. So we need to know that our test equipment works. So I've got my multimeter. I'm going to test on this power point here, this GPO here. So I need to go to AC volts. AC volts. Now, over here, turn the power point on. Let's make sure this actually works. Belt sander comes on, everything good. So now I can test my test equipment on a source that I know is operating. Plug the leads in, turn on, and I'm reading 236 volts, which is what I should be reading. Turn off the GPO, and yep, down to 2 volts, which is acceptable on a GPO. If I swap these leads around, shouldn't make any difference because it's AC. Okay, so now I can go over and I can test on the GPO over here to make sure that it's isolated. Plug in the test leads, turn on, nothing. Or 1.4 volts, but that's acceptable because the neutral is still connected, okay? But the active is isolated, so therefore we've isolated the circuit. So now what I can do is go to my next step, which is, test the circuit. I've already tested the circuit. So what I need to do now is go to the next step, step 6. Test the testing equipment on a known source again. Why do we do this? Well, maybe when I plugged in my multimeter into that source that I think I've isolated, maybe something went wrong with my multimeter. I don't know that. So I need to confirm that my multimeter is still working correctly. Something could have happened to the multimeter in between testing on the known source and testing on the circuit we're working on. So many things can happen. You want to make sure you're safe. So I'll go back and I'll retest on the known source. Step 6. Multimeter, plug into the socket outlet, fire it up, 236 volts. So I've ensured that my test equipment is functional. Now what I can do, I can start to do the job. Right, now I need to take this cover off, because all we need to do is take this motor, disconnect it down here at these bolts down here that's holding it onto the pedestal, and take the motor away. So all I need to take apart is the supply cables into the little box here that's got the terminals for the motor. Okay, so you can see here, there's the active, there's the neutral, there's the earth. I don't want to disconnect those straight away because I want to make sure that they aren't live. So I'm going to test these terminals here to make sure that it's not live. Test equipment, AC volts, red for active, black for neutral. Goggles on so I can see. Now, metal of the terminal, make sure you've got metal to metal contact. I've got nothing there, 0 volts, so I'm isolated. But what do I need to do? Retest my test equipment to make sure that it is isolated. So we'll go back to the GPO that I know is energized. Alright, I know my test equipment's working. Now I can disconnect the supply. Okay, we need to take this cover off here. Pretty easy. Get that out of the way. Now I always put my screws somewhere where I know they are, screws and bits and pieces, because I want to do the reverse of the job as I'm putting it all back together. So first of all, I disconnect the active, then the neutral, then the earth. We do that because the earth is the thing that's saving us, yeah? So if we disconnect the active first, then the neutral, then the earth, that's the proper process. Now you can see here that the earth is actually a ring terminal, right? While the phases, the active and the neutral, are spade terminals or fork terminals, yeah? This is because this is the thing that's doing the saving of your life. If that's always connected, you're safe. It's less chance for a ring terminal or a round terminal, lug, to be disconnected than these ones. They can slide out, that one can't go anywhere. I'll just put that back in. Okay, next thing we have to do to get this disconnected is we have to take this gland off. So all I've got to do is on the back there, I can disconnect that there like that. And that brings that stuff out there. And there we have it. Supply is disconnected. Now all I need to do, put the cover back on. Oops. Don't forget this cover. Put that on there like that. That on there. Right, and now this machine is ready to be taken away and see what's wrong with it. Okay, now we've taken the motor off. Now we've got to make this safe. We've got to make sure that no one's going to come along and put their hands all over this. So we need to put an out of service tag on it. But we need to make this safe first. You never know, some person could come along and plug this in, take that danger tag off, do all the wrong things and really hurt someone. So we've got to make sure that we've taken all steps necessary to make it as safe as possible. Now you might say, well, what's the tag going to do? Someone could take the danger tag off. Yes, someone could, but there are laws, WHS laws, that forbid the removal of a danger tag. If you're the one who put it on, you're the one who's got to take it off. Same with an out of service tag. Now it's a little bit different with an out of service tag, but the laws are in place to protect people. So, the lugs here, all right, I'm not going to cut these lugs off because we'll use these again. We'll connect these to the motor again. But you can probably see that that lug is not easily going to go in that BP connector. So we need to come up with another solution. So there's a couple of ways you could do it. You could get another terminal strip, put it on, tape it up, do all that type of stuff. But for this process, if we make sure that that's disconnected, we make sure that this is just taped up. So we get a bit of tape and we individually tape each of the lugs. Make sure the end's taped so someone can't touch it like that. Give me. One. Now you probably don't have to tape the earth up, but it's always good practice to do so. And now so someone doesn't come along and take everything apart, I'm going to tape all three together back on to the conduit here. There we go. Now, the out of service tag. Fill out all the details on the out of service tag, and then what I'm going to do is I'm going to connect this out of service tag onto the main switch here, the main isolator. So normally you should have a spot where you can connect it on. Once again, I'm going to have to get a little bit creative, but I'm just going to tie it on here. So I'm going to tie it through there, around there. Actually, I'll go this way. Around there, underneath there, onto there. Now it doesn't have to be tied up with a fantastic knot. All it has to have is a loop, because eventually this is going to get taken off. I mean, if you wanted to, you could actually tape this onto here and tie it around as well, or tape it around. Whatever makes people aware that they shouldn't operate this machinery because it's out of service. Okay, so now what I can do is I can go back and take the danger tag off this GPO here, because that could still be used. Okay, you could still use it while this is out of service. And plus, I don't want to be at home one night or maybe sick one day and not be at work, and then this all gets connected back up and someone goes, hey, we've got to take the danger tag off, but the person who put it on isn't here. They'd have to either wait for me to come back the next day or ring me up at home and tell me to come in and take the danger tag off. So I'm going to make that safe now.
Okay, so hopefully that tutorial has helped you understand how we use our 7 steps of isolation and the process we would go to disconnect any equipment and make sure it's safe, so that we can work on it safely without, getting hurt or, heaven forbid, being electrocuted. Because let's face it, as electricians, you are working in an extremely dangerous industry. So we need to make sure that we follow all of these steps correctly so that we don't have any workplace incidents or accidents. Thank you, Mr. Pope, for your excellent demonstrations this morning, and hopefully you have enjoyed this video. And we'll do some more.
Thanks, Mr. Hamlet. Thanks, everyone. Remember, stay safe. Follow the 7 steps of isolation. Look out for yourself. Try not to kill anyone. See ya.
One last thing. Do not forget to clean up.
Yeah, clean up your mess.
All your tools must go back in their safe spots. Stay safe.